Welcome students in the organic chemistry lecture series. In this video we are going to study about how to convert a Sawhorse projection formula into a Newman projection formula. In previous video we have seen how to convert how to convert Fisher projection into Sawhorse projection. In this video we are going to see how to convert Sawhorse into Newman projection. Okay, so we know that if we have to draw the Sawhorse projection formula, then we have to see the molecule from a particular angle. Now consider the example of 3O 2, 3 dichlorobutane dichlorobutane. If I draw the simple structure of this molecule, then it is like this: CH3 CHCl CHCl CH3. Okay, and 3O means the two chlorine groups are on opposite side. This chlorine and this chlorine are on opposite side if 3O means. Okay, so what we have to do, we have to draw first its Sawhorse projection formula. Now I have already explained that we have to see a molecule from any one of the sides. Suppose we are observing this molecule from this side. If we are observing this molecule from this side, then this carbon becomes front carbon and this carbon becomes a rear carbon. Okay, because these two are the stereogenic center here. Okay, now first of all we have to draw this carbon carbon line at an angle of 45 degree to the plane of paper. Okay, suppose this is the carbon carbon bond. Now as I said earlier that the hydrogen and chlorine are on horizontal lines, so I will draw like this. First of all draw CH3 and then we'll draw hydrogen and chlorine here. Now as this is the 3O means chlorine are on opposite side. Okay, so this CH3 will be on the same side, CH3, but chlorine and hydrogen are on opposite side. Okay, so you see here this will be chlorine. Now you see this chlorine and this chlorine are on opposite side. Similarly this hydrogen and this hydrogen are on opposite side. Okay, so this is the Sawhorse projection of this 2, 3 dichlorobutane. Now we have to convert this Sawhorse projection into a Newman projection formula. Now we know that in Newman projection formula, first carbon is represented by a dot and the rear carbon is represented by a circle. This we have seen. Okay, now see, suppose this is the first carbon. Now we are observing the molecule from this side, then this is the first carbon. Okay, so that is represented by a dot, and this hydrogen and chlorine are above the plane, so we will write the same. See, this is hydrogen and this is chlorine and methyl group like this. Okay, now you see this is the rear carbon. Now here also uh, the chlorine are on opposite side. Okay, so we'll draw like this. Here there will be chlorine and uh, here there will be hydrogen, and suppose here there is the CS3, because CS3 groups are on the same side. So you see here CS3 group are on the same side. Hydrogen, this hydrogen and this hydrogen are opposite side, so these are on opposite side. Similarly chlorine and chlorine are on opposite side. You see this. Okay, so we have drawn here the Newman projection form of this 3O 2,3 dichlorobutane, and as all the atoms are near to each other, we can call this as a eclipse form and this is the Newman projection. Okay, now in the same way we can convert this eclipse form into staggered form. Okay, we have to convert eclipse form into staggered form. What we have to do, we have to rotate one of the carbon atom by 180 degree rotation. Okay, so we'll fix this first carbon or um, front carbon constant. We will not rotate the first carbon, we'll rotate the rear carbon. Okay, so we'll write here rear carbon rotation by 180 degree. So you imagine that the rear carbon is rotating by 180 degree and first carbon is remaining as it is. Okay, so I will draw here a dot, that is first carbon, and a circle, that is rear carbon. So a dot, that means first carbon has will have same position of atom because it is not rotated, it is fixed. Okay, but now the rear carbon has been rotated by 180 degrees, so this group will come here exactly opposite to the CS3 group. Okay, this chlorine will come here and hydrogen will come here. So this is the staggered form, staggered form of Newman projection. Okay, so instead of rotating rear carbon, we can also rotate front carbon by keeping rear carbon constant. So in the same way, you can rotate the front carbon also and draw the staggered form of this molecule. So in this way, we can convert a Sawhorse projection formula into a Newman projection formula. The important thing which you have to remember is that do not disturb the stereochemistry while interconverting a projection formula from one form to another form. Say for example, you see here this chlorine are on opposite side. Here also you have to write or we have to draw the chlorine on opposite side. Here also you see hydrogens are on opposite side. Here also you have to draw the hydrogens on opposite side, and the same is applicable to this methyl group also. So in the same way, we can convert a Sawhorse projection formula into the Newman projection formula. So I think it is clear to you that how to convert a Sawhorse projection formula into a staggered projection, new staggered Newman projection and eclipse Newman projection formula. So in this video, we'll stop here and we'll meet in the next video with another example of interconversion of projection formula. Have a nice day. Thank you.